Hi guys, I just want to mention something that I forgot to mention earlier, which is that I actually have a worksheet for all the videos that I upload, and this will usually be in the description of the video and on the pinned comment. And the solution for these worksheets will be uploaded in the next following video. And this worksheet is basically a bunch of questions regarding what I'm saying throughout the video. So you can print it out or you can use it on your iPad, your tablet, whatever, and you can answer these questions as you're watching the video. This kind of ensures that you're paying attention throughout the video and you're not really zoning out and realizing that, oh, I have to watch it again, and then you spend hours on the same video. Because you're focusing on answering these questions, you'll be focused during the video as well, and you'll get through your work a lot quicker. So I hope these worksheets help you, and I will try to upload the solutions in the following video so that you guys can mark your answers and have your notes ready instead of having to write down a bunch of stuff. I've tried to make this also easy to read and easy to follow so that you don't just get lost in your notes. So yeah, I hope this was helpful. Thank you. Next, we have a question that says numbers more than -7. So we're going on the right direction, and then we're not including -7. So it's going to be a circle that's not shaded in. We can draw the number line, and then we have -7 over here. We have not shaded in because we're not including -7, and we're going in the right direction to show numbers greater than -7. So for question 4, we have numbers that are more than -7. So we're going to have an arrow going towards the right direction. We're not including -7, so we have a circle that's not shaded in, and we're going till number 3. And we're saying that 3 is not included. So we're going to have a circle that's not shaded in again. So over here, if we draw a number line, this time we have to write two numbers. We have -7 on the left side, and we have 3 on the right side. And we are not including -7, so on top of -7, we're going to have a circle, which is not shaded in, and we're not including 3 as well. So we're going to have a circle that's not shaded in once again, and we can connect these two to show that we're including all the possible numbers within this range. So now, once again, we have numbers less than 9, so we're going in the left direction, and 9's included, so therefore a circle that's shaded in, and we have numbers that are more than 2, so we're going in the right direction, and we're including the number 2, so a circle that's shaded in. So if we draw a number line, we have 2 on this side and 9 on the right side. And then we look at the circles on top of each of them. For 2, we have a circle that's shaded in, so we're gonna have a circle that's shaded in. For 9, we had a circle that's shaded in, so once again we're gonna have a circle that's shaded in over here as well. Now we have numbers less than 9, so we're going on the left hand side, and on 2 we have numbers that are more than 2, so we're going on the right hand side, and then obviously we can connect these two, and this is our range. So for this question, we have numbers that are less than 2, so left hand side, and 2 is included, a circle that's shaded in, and we have numbers that are less than 1, and it doesn't say if 1 is included or excluded. And a rule of thumb to go with this is that if it doesn't say if a number is included or excluded, we assume that it's excluded. So we can say that 1 is excluded, therefore we have a circle that's not shaded in. And we can once again draw this on the number line, and we have 1 here, we have 2 here. For 1, we have numbers that are less than 1, so going in this direction. And over here, we have numbers that are less than 2, and 2 is included. So like this. Now, there's something that we haven't covered so far, and it's this word over here, and. What this means is that both of these statements must be true, and we'll cover this more later on. But however, for now, the way to think about this is that if both of these statements must be true, then are the numbers in this range true for both of these statements? Are these numbers less than 2? I mean, yeah, they're all less than 2. There's going to be 1.5 over here, there's going to be 1.7 over here, there might be 1.2 over here, and yeah, they're less than 2. So yeah, the first statement is true. We can say it's true. For the second statement, are are these numbers also less than 1? And again, if we look at the numbers in this range, we have numbers like 1.2, we have numbers like 1.5, and so on. And of course, these are not less than 1. So this statement is false. And the AND operator over here requires both of these statements to be true. And the only place where both of these statements is true is in this range over here, where the numbers are less than 1 and they're less than 2 as well. We can simplify this interval into another interval that looks like this. We have 1 over here, and we have 1 being excluded, and we have all the numbers that are less than 1. And you might ask, why is 1 excluded? Why is it not included when 2 over here is included and all the numbers from 2 and less are included? So why is 1 not included? And the reason it's not included is because both of these statements must be true. And the second statement says that 1 must be excluded. And because we require both of these statements to be true, over here, 1 must be excluded. So our final interval would look something like this. So question 7. We have numbers that are more than 3 and 3 is not included, or numbers that are more than 5 and 5 is included. So let's draw the number line again, and we have 3 over here, we have 5 over here, and we have a circle that's not shaded in, and it's going towards the right hand side, and then we have a circle that is shaded in that is also going to the right hand side. Let me just fix the 5 because it looks a bit like a 6. So now we have two intervals both going to the right hand side, and again, similar to an operator that we did not look at earlier, the AND operator, we have another operator over here, that's the OR operator. This OR operator says that either one of the statements must be true. And usually in math, we go with the one that's more flexible, the one that allows us to have a larger range or a larger interval. And over here, we can see that clearly, since 3 allows us to have these many more numbers than 5, which restricts these numbers, we will go with the number 3. And this interval over here can be simplified down to numbers that are from 3 all the way up to positive infinity. So this would be our final answer. For this question, we have numbers that are less than -2, and we're including -2, and numbers that are more than -1, and we're including -1 as well. So we draw the number line, and we have -2 here and -1 here. We have numbers that are less than -2. So again, it's shaded in because -2 is included, and we're going this way. And we have numbers that are more than -1, where -1 is included over here. So this is our interval. However, as you can see, we have an AND operator, which means that both of these statements must be true. And if we look at this interval, or if we look at this number line, we can see that there's no overlap or there's no range where there's a number that's less than -2 and is greater than -1. So overall, we don't have any numbers that satisfy both of these requirements that we have. So our final solution would just be a number line with no interval. There's no numbers to satisfy this, and therefore we would have nothing. Like, we just have an empty interval. If this question had an or instead of an and, so let's just pretend that instead of and over here we have an or. Then in that case, our number line would look like this, and it would not change because either one of the statements can be true. We just want as much range as possible, and the only way we can have as much range as possible is if we allow all the numbers that are less than -2 all the way to -2, and all the numbers that are from -1 up to positive infinity. So if it was an or statement, we would have this graph right here. But since it's not an or statement and it's an and statement, we have this one over here. Question number 9. We have numbers that are more than 5. It doesn't say if it's included or excluded, so we assume that it's excluded. And less than 1. And it says not including 1, so that's the same as excluding 1. So again, an empty circle. We draw the number line. We have 1, we have 5. And it says numbers that are more than 5, we go in this direction. And we have numbers that are less than 1, so in this direction. It's an and operator, so we require both of these statements to be true. In other words, we're looking for some kind of overlap between these two numbers or these two intervals. And since there's no overlap, we would have an empty interval, 1 and 5. And there's no numbers that satisfy this, so it's an empty interval. And our final answer is this. For question 10, now this one is a bit of a longer question and we have to break it down into different parts. So the first part is this part over here. So let's solve it bit by bit. So it says over here, numbers more than -1. So over here, and this one is included. And so we have and over here, which means that both of these statements within this interval must be true. So we have and less than 2, and 2 is not included. I'm going to use two different colors for this. For the first one, I'm going to use blue, and for the second interval, I'll use some other color like green. So let's draw the first interval. We have -1 and we have 2. As we said, we want numbers that are more than -1. So I'm gonna draw it like this now. It doesn't really matter like if you have an arrow that goes slightly up like this part. I just do that so that we can see the overlap more easily, and you guys will know what I mean in a second. And then we have numbers that are less than 2 and not including 2. Actually, I should have this part shaded in. And we have numbers that are less than 2 and not including 2. So over here. So as you can see, it's an AND operator over here. So we're looking for the area where both of these statements are true or where there is an overlap. So we're looking at this area. And I think you guys understand now why I use like an arrow that goes up and then right. Because if we had an arrow like this, -1 and 2, and we had this instead, so it goes like this and the other one goes like this. It's like, I mean, you can still see which area is the overlapped area, but I think it's just easier to see it over here. So we'll just continue with this notation. So the first section of this question gives us the range from -1 to 2. And we have it like this. Now for the second part, which is over here. We have another number line, and I'm just going to do the number line first this time. And let's look at what it says. It says numbers more than 5, so more than 5, and we're including 5. And we have numbers, we have an AND operator, less than 6, and we're not including 6 over here. So let's draw number 5 and 6. And over here it says numbers more than 5. Again, 5 is included. Numbers more than 5. And we have 6 where 6 is not included. And numbers less than 6. So we're going in this direction. It's an AND operator, as we can see over here. So we're looking at the places where the intervals overlap. So we have this shaded region. So this gives us the interval from 5. So it goes from 5 all the way until 6, like this. Now between these two intervals, or between these two ranges, we have an OR operator. As you can see, we have OR over here. So if we combine these two together and we create a larger number line over here, and we have -1, we have 2, then we have 5, and we have 6. And we can draw the interval again on a number line that combines both of these intervals. And it will look something like this. Because it's an OR operator, it means we're trying to have the maximum possible range, meaning that we accept both this interval and we accept this interval on the same number line together. So the overall solution is that we have an interval which is from -1 to 2, where -1 is included, or we have numbers from 5 to 6, where 5 is included, which satisfy the overall requirement of this question. So our final solution would look like this. So for this question, it says that we're looking, again, we have two parts for this question, so I'm going to use two different colors. So we have this part, and then we have this part. And just like the question above, we're going to solve them separately and then combine our results together later on. So first part reads that numbers more than 5 and not including 5. So a circle that is not shaded in, and less than 2, and we're not including 2. So let's draw the first one. We have the number line, we have 2, and we have 5. The operator that we're looking at is an AND operator. That means we're looking for a place where both of the statements are true, or where there's an overlap between the lines that we draw. So over here we can say numbers more than 5, so we can draw it in this direction, and for numbers less than 2, so in the opposite direction. And since it's an AND operator, overall we have a number line with 2 and 5 and with no interval at all because there's no overlap. For the second one, we have numbers more than 5, and we're including 5 this time, and less than 6, and we're not including 6. So on the number line, we have 5 and we have 6. We're looking for numbers more than 5, so we shade this in and we do more than 5. And then we have numbers less than 6 and we're not including 6, so we can draw it like this. In between these two, we have an AND operator, meaning again that we're looking for an overlap, and clearly we have an overlap over here. So our final interval is this region with 5 and 6, and we have the 5 shaded in, the 6 not shaded in, and this area. The 6 is not shaded in because we need both the conditions to be true, and the condition on this side says that we don't want to include 6, so 6 won't be shaded in. Now overall, we have an OR operator in between, so either one of the conditions must be true, meaning that we're looking for the maximum possible interval range. So overall, if we were to draw this again, we will have 2 over here, 5 over here, and 6 over here, and our final interval would look like this, because this interval over here is not contributing anything since it's empty, and we have this one, and because we have an OR operator, we want the maximum interval range, so this part of the interval is what we're looking at, and that would be our final answer. For this question, we have two major parts, which is this part and this part. But the green part consists of two more parts. So we have this part, and we have this part, and the pink part itself consists of two more parts. So we have this part within the pink part, and I'm actually running out of colors here. We have, I'm going to use rainbow, we have this part. And it's separated by this AND operator. So let's solve each of them one by one and then combine them later together. So let's do the blue one first. We have numbers less than 5, and it says inclusive, and less than 4. We can draw the number line. So we have 4 and 5. And we're looking for numbers that are less than 5 and they're less than 4. Like this. It's an AND operator, so we're looking at this region. So overall, we have this interval with 4, and 4 is excluded, and we're looking for numbers that are less than 4. Now, for the second part, we have a few more steps and different ways to combine our answers. So we'll go through them one by one. So let's look at this part over here. For this part, it says we're looking for numbers that are more than 6 and more than 5. So on the interval, we have 5 and 6, and we have numbers that are more than 6 and numbers that are more than 5, and 5 is included. Because it's an AND operator, we're looking for an overlap, which is this region. So overall, we would have an interval where we have 6, and 6 is excluded, and we're going in the positive direction. We also have an interval, and I'm going to use rainbow for this, I hope it's not confusing. We also have an interval where we're looking for numbers that are less than 9, and 9 is included, and more than 7, where 7 is excluded. So if we draw the interval over here, we're looking at numbers 7 and 9, and we're looking for numbers that are less than 9 and more than 7, like this. So overall, we would have an interval that looks like this. Now, for the third part, we are looking for numbers that are more than -3 and less than -1. So I'm going to draw this one over here. We're looking for numbers that are more than -3 and that are less than -1. Again, we have the AND operator, so we're looking for this region. So for this part, we will have overall an interval that looks like this. Now, for these 3 intervals, for all of them, which is the same as this part over here, in between all of them, we have the AND operator and the AND operator again. That means we're looking for an overlap between all 3 of these intervals. So that's what we're going to do next. We're going to try to draw an overlap between all these intervals. So we have a longer line over here, like this. And we can draw our first interval, which is this one. I'm going to write 6 here, and it's going in the positive direction. So this is the same interval over here, just being mapped down over here again. Now, for the rainbow interval over here, we're looking at numbers 7 and 9, where 7's excluded and 9 is included. And we're looking at this region. And finally, we have this interval over here. We're looking at numbers -3 and -1. We have both of them excluded, and we can connect the two. Now, you might think initially that since we're looking for an overlap, that the overlap is in this region, and that our final interval is 7 and 9, and that's it. However, that is incorrect. That is because we're looking for an overlap between all 3 of these intervals. That means we were looking for a region where all 3 of them overlap. So we need to have 3 lines on top of each other, like this. Maybe if we had 2 over here, then we could say that, okay, we have an overlap over here, and this is the interval we're looking at. And I'm saying that we have a 2 over here, assuming that 2 is paired with one of these intervals. So 2 is paired with -1 and 3, and over here maybe we would have 2 and numbers greater than 2, which is when 2 would be valid. If 2 was an interval of its own, then it would not be valid, because in that case we'd be looking for 4 overlaps. So what we can say is that our final interval would be empty. It would have no values, because there's no number that fits in all 3 of this one, of this one, and of this one. There's no number that satisfies all 3 of them at the same time. So the interval is empty, and therefore we would have this interval. I would just like to reiterate the example I gave with the number 2. I'm saying that suppose that 2 was in the same interval as -3, -1, and we have 2 over here. If it was in the same interval as this one. So this is the same interval. Over here we have 2 instead. In that case, 2 is valid. In that case, if we had 2 over here, then we could say that all 3 of these intervals are satisfied, and therefore our final answer would be this interval over here. If, on the other hand, we had 2, not like this, but rather as a 4th interval, so 2 is on its own, like this, in that case, we need all 4 conditions to be true, and therefore this area would still not be sufficient because we only have 1, 2, 3 lines, but we need 4 lines. So even then we would have had an empty interval. Okay, however, our question is still overall not done yet. We know that for the second part over here, we know that for this part that we have an empty interval. However, the operator that we have between this part and this part is an OR operator, meaning that we're allowing for the maximum possible range. So basically, this interval adds nothing. This part adds nothing to our solution. That means it was the same as looking at this part, because we're looking for the maximum possible range. The second interval gives a range of 0. That means the maximum possible range comes from this interval. So our final answer would be an interval that has the number 4, and we're looking at the range of numbers that are less than 4 and not equal to 4. So our final answer would be this. So for this question, we have 2 parts. We have this part and we have this part. Let's number them 1 and 2. And the operator that we have between them is an OR operator. Part 1 has a few more parts, so let's look at them. We have this part, then an AND operator, and then we have a bigger part which looks like this part, and the pink part itself consists of 2 smaller parts, which is this one with an AND operator, and we have this one. So what we're going to do is we're going to work with the green ones first, then the pink, and then the blue. And then we're going to combine blue 1 and blue 2 to get to our final answer. So let's do the green one. We'll do this one first. So we're looking at numbers more than -2 and less than 3. We can draw the number line. We have -2 here and we have 3 here. We're looking at numbers more than -2 and less than 3. It says AND, so we're looking for an overlap, which is this region. So we get a final region of numbers from -2 to 3 where negative 2 is included and 3 is excluded. And that is the answer to our first one. Then let's look at the second green over here. Over here, we're looking for numbers more than 4 and more than 2, and 2 is inclusive. So let's draw the number line. We have 2 and 4. We're looking for numbers that are more than 4 and more than 2. Because it says and, we're looking for an overlap. So it's just the region where we're looking for numbers more than 4, where 4 is not included. So we get this region. Something like this. Now let's look at the third green part, which is this one. Over here we're saying we're looking for numbers less than 8 and more than 6. So let's draw the number line. We have 6 here and we have 8 here. It says numbers less than 8, so we go in the negative direction, and numbers more than 6, so in this direction. So because it's and, we're looking at the overlap, so it's this region, and we get a final interval from 6 to 8, where 6 is included and 8 is excluded, and this is our final answer for number 3. Now, if we look carefully, we can see that number 2 over here and number 3 over here are connected by an AND operator. So we're looking for an overlap between these two intervals. So let's do that now. We're gonna write 2 and 3. So let's put both of these intervals on the same number line. We have numbers that are more than 4 and then we have numbers from 6 to 8, like this. Because it's and, we're looking for an overlap, so it's gonna be this region. So overall, for this part of the question, we have numbers from 6 to 8, like this. And this is our final answer for the pink part. Now, if we look carefully, the pink part over here and the blue part over here are connected with the AND operator. So I'm just going to label this as 1.2 because it's from the same branch. So they're connected by the AND operator. That means that we're looking for an overlap between this interval and this interval over here. So let's draw them on the same number line and see what the overlap is. I'm going to do this part in blue now. So let's draw the number line. We have -2 and 3. And then we have 6 and 8. And we have numbers from -2 inclusive to 3. Sorry, I missed the 8 over there. And then numbers from 6 to 8. Now, if we go up, we can see that we have an AND operator. So we're looking for an overlap. And as we can see, there's no overlap over here. So overall we have an empty interval, something that looks like this. So part 1 gives us an empty interval. Now let's look at part 2. Part 2 says that we're looking for numbers that are less than -5 and they're less than -3. So let's draw the interval down here. We have part 2 over here. So we had -5 and -3. If we go back up, it says numbers that are less than -5, and -5 is included. And numbers that are less than -3, and -3 is excluded. It's and, so we're looking for an overlap, so it'll be that region. Then we have a final answer of the region where we're looking at numbers that are less than -5, where -5 is included. Now between 1 and 2, if we see over here, between 1 and 2, we have an OR operator. That means that we want the maximum possible range. So to combine them, we have an empty interval that contributes nothing versus an interval that has numbers all the way from -infinity to -5. So to combine them, our final answer would be an interval from -5 till infinity, because that's the maximum possible range we can have. So this is our final answer. So for question 14, we have 3 parts. We have this part, and this part, and we have this part. So let's go through them one by one and then combine our intervals in the end. So let's label them 1, 2, and 3. For the first one, we're looking at numbers greater than -4 and less than 2. So we can draw the number line and we can write down our numbers. We have -4 and 2, and we're looking at numbers that are less than 2 and that are greater than -4. There's an AND operator in between them, so we're looking at the overlap. So together we get the interval, and we're looking at all the numbers in between where -4 and 2 are not included. Then for the second part, don't let these extra brackets confuse you or make this question feel harder than it is, because it's the same thing as what we've been doing before. We're looking at numbers that are more than 5, where 5 is excluded, and less than 9. So as normal, we draw the number line. We would plot down our numbers. We have 5 and 9. We're looking for numbers that are more than 5 and numbers that are less than 9. And there's an AND operator, so we're looking at the overlap. And finally, our interval is all the numbers from 5 to 9, where 5 and 9 are excluded. Then for our final interval, we have numbers that are greater than 7. So we draw our number line, we plot down our numbers, and we're looking for numbers that are greater than 7. We can't simplify this further, so we can just leave it like this. We would have numbers that are greater than 7, and that's our final interval. Now, in our previous questions, we've always had the same operator between our groups of intervals. So we would have always have had AND, or we would have always have had OR. However, in this case, we have OR one time, and then the next time we have AND. So how do we combine these? For this, we need to remind ourselves of BIDMAS, which you might have learned in high school. We have BID MAS, which basically tells us how to combine a list of operations together. So it would tell us that we always have brackets first, then indices, then division, then multiplication, then addition, then subtraction. So similarly, there's an order of operations for logical questions as well. And we always do the AND operator first. So the AND operator connects this interval and this interval together. In other words, interval 2 and 3 together. So we're going to combine them together with an AND operator first, and then combine our resulting interval with the first interval that we have. Let's do that then. We have 2 and we have 3. We will draw both of these intervals on the same number line. We have 5 to 9 and 7 and more. So 5 to 9 and then 7 and more. So AND operator, so we're looking for the overlap. So our final interval would be the numbers from 7 to 9, where 7 and 9 themselves are excluded. And that's our final interval for 2 and 3. Now we combine this interval, our resulting interval, with 1 over here. And as you can see, we have an OR operator, so we're looking for the maximum possible range. So let's plot them together and see how we can get the maximum possible range. We have 1, or I'm gonna put 2 and 3, like this. We're gonna put the intervals on the same number line. So we have -4, 2, 7, and 9, like this. We would get the maximum possible range if we accept this and if we accept this. So our final answer would be this interval.